He's telling me that it's necessary that people to use the microphones.
For questions, yeah.
So
Understood.
the slides can.
Yeah, understood. So, test 1 2 1 2. Do we have it on? Do we have it on? Test. Test. Test.
Yes.
Yeah. More test. More test. Test. Duizend oceanen en daarbij het Egemeer zijn vergeleken bij mijn... Ja, okay. This morning, I'm going to the DNS school website just to go through what we went over. We started this morning with some description of classic DNS. We skipped Unbound in practice, basically because it's a very deep vendor not so vendor neutral thing. Then we talked about DNSSEC in theory and the security fundamentals. And then I lost my screen, which I hope I get back very soon. This black shade is me, that's my glasses. Anyway, we went all over that, yes. What we didn't talk about is the DNS keys. I don't know why this is in Dutch. I do know why it is in Dutch, but I don't know why I haven't translated it. But we're going to talk about DNS keys today, this afternoon, in a little bit more detail, and we're going to talk a little bit about what sort of things do you need to take into account if you do DNSSEC deployment on the authoritative side. What you have to do on the validation side is actually fairly minimal. And I was looking up whether things were working on my side, and I ran into one important site that can be of help and assistance if you... It's the DNSSEC deployment site, www.dnssec-deployment.org. Oops. What you can see here is that my... Hey buddies, can I get my screen back? Thank you. What you can see here is that DNSSEC validation has been turned on for the server that I use. I run DNSSEC validation on my laptop. But there was a news item there, October 3. DNSSEC gets more useful in Windows 8. Actually, they're working on DNSSEC implementation for validation in Windows 8, which is, I think, very good news. So turning on DNSSEC validation will be easier for most people who run a Windows shop. Now, I do want to, and in general, there are a bunch of sites that are very useful in giving you a little bit more background information on the deployment of DNSSEC. Also, during the break, I was asked by Gonzalo Romero, who is running the .co TLD, or he's the CTO there, a CSO, I should say. Where you can find best practices and how you build a quorum of people that actually know and do DNSSEC. There are a few places where people who do DNSSEC gather around. The DNSSEC deployment group has a web mailing list where you can find people. There are user mailing lists that have good people. But it occurred to me that there is no Spanish, as far as I know, there is no Spanish language repository of information. And I think that for this community in particular, there might be a chance to work together and share experiences if you do DNSSEC in your own language. Having people to ask questions, no matter how stupid they might look, and having a place where you can say, hey, I've got this operational problem. I really cannot validate a particular a domain or a particular zone. Is it something that I do wrong, or do other people see that? Is a very valuable resource to have. Yeah? Oh, sorry. So I believe that Colombia has a initiative going with some information in Spanish. Maybe you want to step up to the mic and give the link to that. You have to talk into the microphone for the interpreters too. And you can say it in Spanish. I will pick up the...
Okay. We are creating a DNS community called co.dns in order to promulgate and make awareness of the use of the DNS. And we would like to offer that community. You can type co-dns.cointernet.co and see what we are trying to create now in Spanish language.
So what you're saying is, I'm cheating, I've got it written down here. It's co-dns, oops, co-dns.cointernet.com.co. That is the domain you're talking about?
Yeah.
So that's at least the start of a place where you could go for Spanish language and could actually contribute if you would like. I don't know if there's other initiatives going on. If there are, it's probably good to share them with your community. I don't know if you have any mechanisms to do that. But you know, having a place where you can share experiences is actually important.
It's a very short community now, but we need to expand it and within our countries in order to share comments, share information about the DNS and the technology and the security of the DNS.
Yep. Based on what we did this morning, are there any questions at this moment? Ah.
Puedo invitar o incluso
I can invite you to our community, or you can even log in to the webpage and become a member and be a part of the community. You don't necessarily have to be invited. Anyone can be a member of the community. It's like a small Facebook. This is the new trend to create these types of communities, not necessarily using mailing lists because people are not really using them. So this type of project allows people to really become a member of a community and be part of it. And right now, the community is closed, but I can open it and I can invite you for you to be a member for the community. You can write co-dns.cm and you can log into the page through that link. It's basically the same. Yeah. Right now, what we're trying to do is to create this community through trust, that there's some trust in this community, not that just anyone can participate, but if you're part of the community, then you can invite other people who might consider it interesting. Right now, if you want to log in to the community, then you can send an email to the previously mentioned address, which is CEO DNS at cointernet.co, and I can get those mails and I can invite you to join our community. That's how we're doing it right now because we're still in the process of uploading and creating the page and constructing it. In this community so far, we created a sort of event in July for usage of DNS, and most of the people who came, most of the people who participated worked with this DNS, and we have a list for the participants and we can invite them over. So I think it's a very interesting way of creating awareness for the whole of Latin America and Spanish-speaking countries, and talk about DNS technology. And when you log in, you can see different videos and on different speeches that were given with regards to this. You can all email me right now or share a card with me, and I will gladly make you members of our community.
I am just talking about...
I followed everything
okay.
through the fantastic interpreters,
okay.
Yes.
Thank you very much.
Thank you. Yep. So share those business cards. Obviously, that's one of the most important things of meetings like this, that you share information with each other. Oh, sorry. Yeah. Anyway. Okay. So what I have not talked about is how you enable DNSSEC at a validating recursive name server. And actually, it is very, very simple. I'm going to give you the example for Unbound, so to speak, our product, but there are other products as well, like Bind, like Power Recursor, that will do DNSSEC as well, validation, and it's fairly easy. What you see here is an example of the configuration file of Unbound. The only thing that you need to do is fill in the auto trust anchor file, which contains the information about the key set of the root. Once you've done that, and you keep the system running and nicely online, the server will validate anything it can from the root down, and it will actually, because it's auto trust anchor, it will actually fetch new keys if the root key is ever rolled over. So it takes one line of configuration, the auto trust anchor file, to turn on DNSSEC and actually use it. One line. That said, once you do that, you do need to know how to troubleshoot. Troubleshooting is another fairly generic work of art. There is a set of slides on the USB stick and on the on the USB stick, and I'm going to show you very quickly. I'm going to run you through the tool set so that you, or the troubleshooting tools, so that you at least have an idea of where to go and how to start troubleshooting if you need to do that. So this is for the people who are actually going to turn on validation on bind, on unbound, or any other product. It is targeted for those people who do the hands-on DNS administration. It's not targeted for those people who do the authoritative servers. If you do the authoritative service, you need to know this as well, because you need to solve the problems you cause yourself. But this is really for ISPs and so on and so forth, who have a recursive name server and say, okay, we want to validate. I know for a fact that the Dutch ISP T-Mobile, the T-Mobile operator it's a big mobile operator in the Netherlands. I don't know if they have market presence anywhere in South America. But T-Mobile in the Netherlands, for its whole mobile users, so everybody with an iPhone essentially, they've got the DNSSEC turned on and serve it via Unbound. So everybody who's using a handy, a mobile back in the Netherlands is DNSSEC protected, which I think is fairly good news. Anyway, what do you need when you want to do troubleshooting? There's a whole tool bag of tools. Dig, it's the tool that comes with bind. Drill is a tool developed by Nelnet Labs. Lives in many package management systems. You can just download it, or you go to our website and you download LDNS and Drill. Unbound host comes with the Unbound package. And there is a bunch of packet analysis tools. If you really want to know what's going on the network layer, Wireshark, TCP dump, and DNSCAP, which is a capture library developed by IIC, I believe. I'm not sure. Robert, is that IIC, DNSCAP? Yeah. So try and understand what is going on the wire. The examples that I gave you this morning with the resource records and their content is basically, you know, what you try and have to understand. A DNS packet has 4 sections: question, answer, or authoritative, additional. We sort of want to know what is in there, what everything means, how that translates to material that you find back into your dig response. Because all the stuff that lives in headers, this is a schematic of what a DNS header is, and I won't go into the details, but all this stuff, all the meaning of these bits that are relevant, you can find back in the header of dig output, for instance. You know, so it's all there. If you use Wireshark, this is Wireshark. It's a packet capturing program that you find on Unixes, Linux, and so on and so forth. You can also compile it for your MacBooks. You can actually go into the packet and you can actually see what flags there are, and you can dissect the header information. All that stuff is there as well. So this is your bag of tricks. And basically knowing how to find it and knowing how to read is something that you will have to learn if you do extensive troubleshooting. One of the important parts in doing DNSSEC is that DNS was designed with a packet size of 512 octets in mind. So everything that you got back needed to fit in 512 bytes. Well, I showed you this morning that those DNS resource records could be pretty big. You know, you have the binary material there, you have a couple of keys, there's a signature with everything. Before you know it, you're out of space on 512. Now, fortunately, there's a protocol extension called eDNS. And eDNS allows you to signal that you can handle more bytes. In theory, you can go up to multiple Ks of data. But in practice, what you will see is that there might be problems with so-called packet fragmentation. If you send a packet that is larger than the MTU on your network, so the size that you have available on your network, the packets will be split up and they need to be recombined at some point. There are many firewalls that won't allow fragmented packets through. And that means the DNSSEC might fail at that moment. The software itself has all kinds of mechanisms to fall back and probe and figure out what the right length is. But these are things that you have to keep in the back of your mind. If you turn on DNSSEC and everything fails, think firewall. Yeah? The firewall component that sits in your network might block stuff that it doesn't know. It might drop fragments. If half of your queries go through and the other half not, think firewall. Think network components that block EDNS0, that block UDP fragments. This is one of the trickiest parts of deployment. For instance, because many of those little net boxes that people have in their houses, the home routers will not do this properly. If you really want to have a deeper understanding, if you go to the DNS parameters on the IANA page, this is the technical parameters, all the packet content and everything it can mean with links to the RFCs. If you really want to learn a lot, that's the thing you want to read. But that's only for the real, the real hard-on hackers that really want to know what's going on. So what can go wrong? Well, local configuration. DNSSEC is critically dependent on time. If you find DNSSEC validations all the time, check your NTP configuration. Run NTP regardless. NTP is Network Time Protocol. If you don't know what it is, look it up on Google, install it, compile it, have it work. Use date-u with that particular string behind it, and you get the content as it's being reflected in the signature, expiration, and insertion date of your RRSIC field. Check those signature validity times if you find anything goes wrong. These are things to keep in the back of your head, and you open this slide set when you have problems and you go through them. This is unreadable, but in essence, this is the signature validity time. And if you do a date-u, you get output, and this output should be between those two values that are in the RRSIG. Don't bother reading this. Secure delegations. Are there DSs? Are there matching key IDs? Is there an NSEC proof that it works? This is the kind of stuff that is hard to do manually. Log files of both unbound and bind will give you information if you have the appropriate logging turned on. But one of the tools that we developed at the Nelnet Labs, Drill, has some mechanisms to try and figure out whether is something wrong with the NSEC change or validation. It gives a useful indication of where things can go wrong. Drill comes with two flags, -T or -S. And basically, the difference is walk the chain of trust from the root down and take everything and try to accomplish path. And chase means start at the bottom of the tree, or the top of the tree. How do you say that? That's what the trees. Anyway, start at the end of the end name and try to work your way back to the root and find out what goes wrong. They have a slightly different interface, and using them both is actually very handy to figure out what might have gone wrong. Same is output with dig. If you use dig sig chase, it will do the same as the drill -S. So you don't have to install the Nelnet Labs tools, but I would advise you to make your arsenal of troubleshooting tools as big as possible, and just try them all out. One of those might work for you, other ones might not. Oh, another thing, DNSVis is actually a pretty nice visualization site of things that might go wrong. So this is an output of drill -s. It tries to build the trust tree going from example.net with all the key tags. It builds the tree all the way end to the end, and it says chase successful. So, and this is output of drill -t, which is much more complicated, and I showed an example before the break of that output earlier. But what you can see here is the T, trusted, trusted, trusted. Well, you cannot see it here, but on the screen, but the idea is that you can see where things are trusted and where trust breaks. And it gives you reasons. This is the output of the DNS visualization tool. It shows all the dependencies, and it shows where the dependencies break. There's a DNS key here. There's no link between these things, which means that DNSSEC is broken between that zone and that zone. Also, a very nice external tool to do troubleshooting, because if you think that something is broken and you think it's your problem, it might actually be that the problem is caused at the authoritative side, and you're not the only one that's seeing it. And then looking at DNSVis is actually a nice way to troubleshoot if you're not causing the problem. Look at the validating signature. What happens, it's very important to know. If you turn on DNSSEC on your validating name server, then as soon as validating fails, then the name server will respond with no error at all, no answer at all. It will say serve fail. You don't get an answer. DNSSEC validation failure means black. No service. There's no override button, it just goes black. This is how security is intended to be. If it breaks, it breaks. If you do troubleshooting, there is a little flag that you can set with dig and with drill. It's called checking disabled. One of the things that you do is you query a name server for a broken record. It will say, it will give a serve fail. If you then check with the CD bit, so you do dig at your name server, your recursive name server that does the validation, a question name plus CD, you get an answer, then it's very likely that you have a validation failure. Yeah, because checking disabled means it's a signal to the recursive name server that says, give me anything you have and don't check on it. Transport problems, I just covered them. UDP might see fragmentation because of firewalls. There is usually fallback to TCP, but TCP port 53 is often blocked on firewalls, or sometimes blocked on firewalls as well. If you run a DNS infrastructure, make sure those firewalls do take care of UDP traffic and TCP traffic. Both are needed. Again, the idea is that you don't remember this actively, but as soon as you run into a problem, you have this in the back of your head and you can find this. On your service, Unbound, you can set log levels, print queries that failed, print reason why it failed. Bind has similar options, and you will see something in your responses that look like this. And what we have is Unbound host, which comes with the Unbound package, which actually does this on the command line. So you don't have to open the log, but you just say Unbound host with -DDD for high verbosity, and you get all the information back that might help you with troubleshooting. There's a bunch of troubleshooting tools. Just keep them in the back of your mind if you do turn on validation. And really, since the root is signed, since .org is signed, since there is .co, .br, since there's a whole slew of things signed, consider turning it on. Consider turning DNSSEC on. First, do it in your lab. Make sure that whatever you do is, you have external visibility. You're not causing too many false positives, because things will go wrong. There is a cost that comes with it a bit. But once you turn it on, it will run like a dream. Very little can happen. It's just ordinary DNS. The OPEX involved is really low. The OPEX is you have the server already. If you have bind or unbound, you have the server already. You only have to configure something. The OPEX is a little higher because the troubleshooting is sometimes more difficult. Yeah. Now, we're going to talk about key rollovers. Again, this is tough stuff. And the reason, again, why I'm telling this is that DNSSEC didn't make DNS easier. That's a bit unfortunate. However, lots of this stuff is currently being worked into automation. If you look at the developments in bind, then you see that between version 9.6 and 9.9 that is forthcoming, there have been a lot of extra tools introduced that make automatic re-signing, key rollovers, and that kind of things a little bit more easier. At the Nelnet Labs, we're collaborating in a project called OpenDNSSEC, which is intended to be a bump in the wire solution. You can place it inside of your infrastructure if you want to do authoritative DNS fairly easily, and all the magic of key maintenance lives in that product. Key rollovers, key signing, everything that you need to know. But I'm going to show you what the theory is behind all this. Yeah? Good information to look up is on the DNS School website. There is, in the references section, there's a bunch of RFCs. RFC 4641 is DNSSEC operational practices. That's one you want to have a look at. But there is also an update forthcoming, which is currently still in a draft. And there's also a pointer to that draft in the list of RFCs somewhere at the bottom. That is something you might want to read if you want to know a little bit more about the theory behind all this. A question so far? So, who is now actually considering turning on DNSSEC when they come home on their validating name servers? Ouch! Come again? No, yeah, no, then you already made your decision. Yeah, yeah. Oh, so I didn't meet my goal. Not yet, at least. And I know why. This stuff is intimidating and complex. But in one way it is, and in one way it isn't. Because once you start doing this, you'll see everything falls into place. Anyway, DNSSEC, DNS keys come in flavors. You have zone signing keys and key signing keys. Those key signing keys function as a secure entry point into your zone. Those are the things that are pointed to by the parent, or they're configured as a trust anchor. That's why we call them a secure entry point. It's the thing that needs interaction with third parties, so you're a little bit more careful with it. DNS keys in the protocol, they're all the same. The protocol doesn't care. If they see a DNS key, well, as long as things validate in some way, they don't care if the key has a flag that says it's a DNS key or it's not. You can, as an operator, make the distinction. If you stick to the convention, and I suggest you do because it makes life for everybody easier, by setting the KSK by putting it in the flag field, which means that the flag will be 250, will be odd. Anyway, the benefits, I already explained. Rolling your KSK needs an interaction with a third party. It's usually expensive. rolling of ZSKs, zone signing keys, can be done almost instantaneously. If you change your KSK, it might mean that people who rely on your key as a trust anchor need to get informed. That's even a harder part. Make that the problem of the root, or maybe of the TLDs. The TLDs, you know, some TLDs have provide the choice that you can configure their key, but then they should also offer mechanisms so that automatic update can take place. And I'll be talking about that a little bit later. So those ZSKs, zone signing keys, might be touched on a day-to-day basis by junior staff, and those KSKs might be only touched by senior staff. That could be a distinction you make operationally and for somewhat higher value keys. I mean, this is all writing down your security policies and thinking about that. Now, one of the things that you cannot do is roll your keys instantaneously. If you think, I'm going to change my keys now, like I'm going to just replace a key, things will break. And that is because information in the DNS is cached. Remember, if you ask a question, you get an RR set with a signature attached to it, and that is atomically cached inside of a cache. At the same time, you also have asked for a DNS key set, which lives in that cache as well, and they might have different TTLs and different timing parameters. So these things live in caches and might be fetched at one time and might not be fetched at another time, and all the time consistency needs to be happening. You need to be able to validate material that lives in a cache with the keys that are currently at the authoritative servers, or you need to be able to validate material that's currently served by the authoritative data by the keys that currently lives in caches. If not, you get validation failure. So when you do the operational rollovers, if you change a key, you have to take that into account. That's very important. If you run an authoritative server, you really need to think about timing issues. How does this work? Well, suppose that I have a key. The key is, suppose I have a text record in the DNS, and the text record is published on an authoritative master server. The authoritative slave servers will pick up that data based on timing parameters in the SOA record. This is internals of the DNS protocol again, but in theory, there is a timeout value whereby authoritative servers sit and wait and wait and wait, and then once the timer is zeroed out, they go to the authoritative master and say, do you have anything new? And then the authoritative master says no, and this secondary server goes back and sits and waits and waits and waits and waits, and then they come back and they say, do you have something new? And then the authoritative server says, yes, I've got something new, and at that point the data is transferred. So there are periods of time that there's a difference of content between the authoritative servers. An authoritative server here, NS1, might have different information than NS2. This is why we call the DNS a loosely coherent protocol. It's loosely coherent because everything is supposed to be the same, but because of caching and timing constraints, sometimes data differs in different places, but we understand why. So loosely coherent means it's supposed to be in sync, and the differences, well, we understand and we hand wave away. But with DNSSEC, you cannot do that. Now, suppose that I'm a client and I'm asking something from a recursion caching name server. So the authoritative master server has new record on time 0, has a new text record. The authoritative slave server hasn't received the update yet. It hasn't bothered to ask yet. It's still waiting for that timeout to occur. At some point, say T1, the caching name server is asking for foo.text and will ask that coincidentally to the authoritative slave. it will get thereby the old information. That information will be cached with the TTL that belongs to the foo.text value. So it will live in that cache until it's expired, which happens here. It's only after that query at T2 that the zone transfer is made from the authoritative master to the authoritative slave, and the authoritative slave has the new record. So there is a long time, which is the SOA retry interval, and the TTL on the data, the actual data, that there might be inconsistency between what you've just asked with the signatures attached to that, and for instance, the key set, which still is in your cache. There's inconsistency there. You have to take that into account. Yeah? So this timing depends on zone synchronization, and with dynamic, IXFR and notifies, you can bring this down a time close to 0 if you are sure they work. But in theory, it's a SOA expiration timer that comes into play in this part. And this is the TTL of data. And you have to keep that into your mind because you want to maintain this consistency. So the way you do that, if you roll over a zone key, if you want to roll over a zone signing key, you're signing with a key 1 now, and you're going to sign with a key 2 in a second. What you actually want to do is publish this key 2 well before you start signing with it. Because then, at the moment you start signing with that new zone key, it already lives in caches. You give it the time to propagate through caches, so that all the caches in the world that have an interest in this have a DNS key set with the original key, the key you're using now, and the key you will be using in the future. And then, at the moment that you change the signatures from being made with key 2 instead of key 1, then all those caches will have the data available to validate with. You ask a piece of data, hey, it has a signature made with key 2. Let's go to my cache. It lives there with DNS key 2, lives in my cache so I can validate. So taking into account those key rollovers means that you have to publish data well in advance, and at least so far in advance that all the TTLs can time out of the old material, and things get propagated into that. So when we start talking about that, we start to talk about a published key and an active key. The published key is there. It's the public key that lives in the system. But the private key is not used for anything yet. An active key is published in the system, and the private key is used for generating signatures. In fact, you could also turn this around. You could also say, I'm going to make the signature generation I'm going to do in advance, and then make the key an atomic transition. So you first generate signatures with both key 1 and key 2, you put them in your zone, and at some point you switch from key 1 to key 2, and you know that all the caches contain signatures of 2 kinds. Yeah? But that's very expensive, because signatures are big things, and they all end up in your zone file, making your zone file at least twice as big. So you want to keep those signatures to a minimum, which means the DNS keys are the things that you're going to change. You're going to introduce a new key well in advance, make it published, and wait until it's propagated through the system. Tricky stuff. Tricky timing. You have to keep everything into account, and you actually have to keep a notebook. For every zone, you have to keep a notebook. What is the ZSK I'm using? What is the KSK is using? Is it published? Is it active? Is it retired? That's complicated administration. Yeah? For those who write scripts and programs, this is there's generated, published, ready, active, retired, dead, and removed. There's all kinds of states. And we've been trying to very hard, for instance, at NLNet Labs to understand these key states and their interrelationships. And this is where I personally think mere mortals should not have to care. This is very important that this all gets automated. And we believe, and I'm going to plug up the product that we're involved in, it's OpenDNSSEC. I believe that OpenDNSSEC is close to making that promise true. It's the best bet we have at the moment. I'll be talking about DNSSEC, OpenDNSSEC in a bit too. I'm actually going to plug that. This is essentially what you do when you have to do this manually with the bind tools. With bind tools, you use a tool called DNSSEC sign zone, and then you have to say what your key signing key is and your zone signing key. You have to publish stuff, and then you have to do this again. And you see what happens here. This is the time axis. This is the state of your signature. This is the state. This is the key set, KSK, zone signing key 1, the signature of KSK, the signature with the ZSK, and there's zone data, and all that zone data is only signed with the zone signing key. So the key signing key is signed with 2 keys, the zone signing key and the key signing key, and the zone data is signed with only the zone signing key. At some point you create the published ZSK2, the second zone signing key. That is what happens here. Signatures go with it, made with the KSK and zone signing key 1, and everything else remains the same. You wait for a certain TTL, and that TTL is at least the TTL of the DNS key RRs and the time it takes to propagate to all the authoritative name servers. But you can test that. You have some control over that. Once you're sure those things are, migrated through the system, you can remove the old zone signing key and continue as is. For all practical purposes, at the moment you do this, you introduce your new ZSK3, of course, so that you're ready for the next one. For key signing key rollovers, things are even a little bit more problematic or difficult or different, at least. You're depending on your parent. You cannot control when the parent changes the DSRR. So the parent has a pointer to key signing key 1, and you say, can you please change that to key signing key 2? So you send off a request, and that request might live in the mail queue. It might take an operator or a cron job to get to, and it might take a cycle of signing. I don't know what kind of timing parameters are involved with that. But at some point, the parent will go, okay, this is the DS to KSK1. I'm going to change it to the DS to KSK2. And you actually do not have a time to control that change. So you have to use the old KSK until the old DNS test had the time to propagate from the caches. You have to keep on using the KSK until the old DS that the parent has just changed has been removed from the caches. So here the situation is a little bit different. You have to use 2 keys during a certain time. At some point you create a second key signing key, you generate 2 signatures, the parent rolls from DS1 to DS2 at this stage, and you have to maintain them for at least the time of the TTLs of the DSSRR records. Because if a client tries to walk a chain of trust at this moment, somewhere in this interval, they might actually get the old DS record. And they need to be able to validate a chain of trust using the DS record that is still pointing to KSK1. So they need to be able to validate signatures made with KSK1, that one, and then go through the validation process. And only when you can be sure that those DS records have been removed and purged from distant caches over which you do not have any control, then you can remove the signatures made with KSK1 and stop using KSK1. Difficult stuff this is. And it's funny too. There is an error in the RFC 4641. If you read it, I just want to point out the erratum is that there is a space missing, a tab. That data should go a little bit to the left. And there is a second one there too, which makes it very confusing. But there's an erratum on the RFC. If you read that RFC, there's a problem. What I just told you is basically a warning. In order to do this, you need to do serious key management. If you're a TLD, this is trivial. If you're a TLD, you need to, worry about 1 or 2 or maybe 5 keys at a time. That's no problem. If you maintain a hosting center and you have 40,000 web customers, all with DNSSEC enabled, that is not notebook work any longer. That's non-trivial work. Because for every zone, you have to have keys that are there on a per zone basis. The key signing keys and zone signing keys, so 2 keys per zone. Maybe you would like to choose 1. That is absolutely possible. You can do with only 1 key there. But still, if you do a key rollover, you have to think about introduction of a second key. You have to give that a certain lifetime. You have to do the tricks with everything. And you really have to think about this. And of course, your private keys need shielding too. So now you're there, you have 20,000 zones that you need to, operate and keep secure and do all your craft about. That's not manual labor. Do not even think about it to do that manually. DNSSEC on one zone is difficult enough, so to speak, as an authoritative server, but you can do it manually. But as soon as you have more than 5 zones to maintain, forget manual. Really, don't even try. It's becoming very expensive operationally and you will make errors. So you need tools. Oh, very important. RFC 5011. This is specifically important if your key is used as a trust anchor. So for the root, this is important, and maybe for TLDs. But also, if you're running an enterprise and you want to say, as an enterprise, I don't want to be, for my DNS services, I don't want to be reliant on external bodies. I want all the resolvers that are in my network to be configured with the key of my enterprise, Coca-Cola.com. The enterprise Coca-Cola might say to all its businesses, you have to use our key because we don't want to have any external dependencies here. Yeah? And in that case, you have to think about rollovers, because if a key changes that is configured in external rollovers, how are those resolvers, how are those guys going to know? Well, you can only do that using automated methods. And there is one automated method described in 5011. I'm not going to describe this in detail, but if you hear 5011, then there is a whole set of timers involved with that in order to allow trust being picked up by the recursive name server operators. Basically, a 30-day window called the hold down timer is used in order to spot that a rollover of a key is actually valid, with the assumption that if something goes wrong, it's actually noticed within 30 days. This I leave for the astute reader. Pick up the RFC and read it. This is sort of the description of the timelines involved with how you do this. But as I said, use tools. It's important. Don't do this by hand. So key management, what we talked about, it's not a matter of changing keys. You really have to take into account the dynamic properties of the DNS. Things can live everywhere in the system, and they can live there for a certain time. That's just by design, and the protocol has taken that into account, but operationally you need to take that into account as well. Doing that manually is difficult, error-prone, and will certainly give you false positives. And the problem with DNSSEC is, if you do this wrong, your customers get a surfail. They go on black. An error is indistinguishable from an attack. There's no way that the DNSSEC validator can say, this is an error or this is an active attack. It will just basically everything that is wrong, it will say is wrong, it's an error, it's a validation attack, I'm not going to give out any data. And we have seen in operations problems with key management, problems with signing that have caused problems for instance, big TLDs. It happens, and it happens occasionally for the big guys. If you look at the DNSSEC deployment list, you sometimes see that kind of error go by. Another interesting list is oh, I forgot the name of it, but it's the group that does the educational networks in the US. .edu was one of the first zones that was signed, DNSSEC related, and that was a very interesting example because by federal regulations, the federal institutions were obliged to deploy DNSSEC. And some people did that fairly blankly without really understanding what they did. And at the moment that they forgot about what they did and there was somebody else, a colleague in their feed, in replacing them or so, all kinds of weird shit happened. So if you do this, if you deploy DNSSEC on your zones, make sure that you have an appropriate body of documentation and knowledge. In essence, the operational costs of doing DNSSEC, once you have acquired the knowledge, are fairly low because you can automate using free tools and so on and so forth. The capital investment is high. It's training, mostly, understanding what you do, having an engineer sit down for a couple of days and really test and set up a lab and try to do all this stuff. What I've heard and understood from people who are deploying now is that specifically on validation, the operational expenses are fairly small. On authoritative server side, the operational expenses, once you get everything running, are reasonable as well. But you have to get everything running. So, what is the time when there is a coffee break? Can somebody notify me of that? What? 4:15. 4:15. Got it. That means that we have more time. So let me. This is more the bit of advertisement. I'm going to talk about OpenDNSSEC. must say that as far as I know, Bind 9 up till now has fairly good tools for automating the signing process. Once you got the keys in place and so on and so forth, Bind will do the automatic signing if you configure it appropriately. If you look at the Bind, nice ringtone. If you look at the Bind documentation, you can see the appropriate configuration switches and so on and so forth. But what Bind doesn't have, but please correct me if somebody knows that I'm wrong, is the key management for changing keys and making sure that things are in sync in the face of key rollover and specifically with many keys. I am not aware of other products that do this. This is OpenDNSSEC. OpenDNSSEC is a zone signing tool that automates the process of keeping track of DNSSEC keys and does all the signing of zones. This is your expert system for doing DNSSEC. It is fully open, designed because good key management was missing. The policy handling, the policy of introducing zones, what time do you want to do key rollovers, when do you want to do them, how long should keys be in effect, who gets to touch them. Hardware acceleration tools were not there. You know, there are people who put their private keys on on hardware machines just to be more secure and so on and so forth. And the goal of the OpenDNSSEC team was really to make OpenDNSSEC deployment easier. At the moment, you're asking somebody who does web hosting for a business to maintain a database with 40,000 keys and do rollovers at some point in time and make sure that everything works, then they're going to say, no way, it's not our core business. It's not our core business to run DNSSEC. Our core business is doing web pages, and this DNS thing is to get our customers to them. I would say that's a very irresponsible answer, given that if DNS doesn't work, the customers, not even, you know, the people who want to talk to the customers might not get to the web servers. But I can understand this. If you have to maintain notebooks and databases with 40,000 keys and everything is difficult, well, you know, it's going to be expensive. So the goal was to develop something that would hide that complication from the user. But really, the intention to bring DNSSEC to the masses, or at least to a larger population. People involved, it's a whole bunch of people and organizations. .se, one of the first, I believe the first top-level domain ever signed. Kyrie, Jakob Schlitter, is a Swedish consultant, security consultant, who's been very active in DNSSEC development. Nominate is the UK top-level domain registry. SIDN, the Dutch top-level domain registry. Surfnet, the Dutch academic network provider, who has deployed DNSSEC and is providing that as an operator, one of those hosting firms, so to speak. Synodem, a small one-person shop, and NLNet Labs. We've supplied the DNS knowledge, so to speak. The signer components and all the DNSSEC knowledge is written by us. It's open software with the BSD license. I don't know if you know anything about software licenses, but the BSD license is the most open license available. It's basically grab and run and copy and do whatever you want. If you want to make money of it, feel free. If you want to put it in a closed box, there is no GNU license terms that says if you make any changes, you have to make it available, which is often a high barrier for getting code like this into commercial products. And we actually want to see this happen in commercial products, and everybody who copies this code can run with it and do its own thing with it. The goal is really to make it simple to integrate into existing infrastructure. and make it simple in the sense that it doesn't care about what sort of product you're using now. If you're using Bind, fine, you're using Bind. If you're using Windows, fine, you're using Windows. This is a component that is intended to be placed in your network and with minimal changes to your system architecture provides you with DNSSEC. That's the goal. We're very close. We're not quite there yet, but we're very close in establishing that goal. Key storage and hardware acceleration using standards. Everything is based on standards. So open standards to get data in, open standards to get data out. So that if somebody comes with a better product that uses the same open standard, you can replace it. The goal is to provide an open infrastructure that you can just choose to use or not. There's no vendor lock-in. This is given away. I'm trying to, the only thing is that I'm very enthusiastic about it because I believe it's... So the idea is we anticipate that it will be employed between a hidden and a public master. In essence, there is a master server usually that pushes out data to the other servers. What the idea is that master server is hidden in the infrastructure. OpenDNSSEC is put in between, and signed zones come out at the other side and are put on the real master server. So whatever you did on your provisioning system on this side doesn't need to change. You put in a new network element and shift your whole provisioning system a little bit to the back, put something in the middle, and let everything work and sign. There's an architecture here. There's a signing engine. And a CASP enforcer is a key and a key policy machine, so to speak. Key and signing policy, that's what CASP stands for. The key and signing policy are XML-based files with some configuration, basically saying, I want to have a key with a certain policy, and I want to apply this policy to these 100 zones. And I have a different policy, and I want to apply that to another 100 zones. And I have a fourth policy, and that's the default policy for anything that I haven't excluded. So in essence, policy definitions that are fairly simple and binding those policy definitions to zones. That's all there is to it. Then finally, there is an auditor component that is more or less optional. In the future releases, we will remove the auditor component because sometimes it gives more headaches than it's worth. But it is something that we use in development because it's an independently written checking engine on which compares the input to the output and the enforcer. So we do the same thing twice independently to make sure that we don't make mistakes. How to sign a zone is described in the policy. What do you choose in this policy? Key strength, algorithm, key and signature lifetimes, all those things that you find back in these resource records. If you want to use NSEC or NSEC3, NSEC and NSEC3, what was the difference again? NSEC, you could do zone enumeration. NSEC3 was the thing that did all the hashes, so you couldn't do zone enumeration any longer. Yeah, that's can have anything between one policy for all zones to one policy per zone. You know, everything is possible. Everything under the sun. Everything under the sun. The CASP enforcer, that's the little demon that does all the magic, handles the management of keys, says to HSM, please create a key. HSM is a hardware signing module. And for those who don't want to buy expensive hardware signing modules, there is a tool called Soft HSM, which emulates a hardware signing module in software. So Soft HSM is a little bit of a strange name, but it's an open source project that is affiliated with this. And the idea again is that you can interchange a piece of software with a piece of hardware or just the other way around. Always based on open standard. It has information, it knows about key rolling. The key and signing policy engine knows when to roll keys, how to do that, what the timings are. It will maintain the state of all these things and choose the keys. HSM is the hardware security module, stores the keys, hardware acceleration is possible, uses a standard API, PKCS 11, that's for the software writers here, and it's abstracted into a specific library, details, but important is that there is a software engine for it. Then the signer. The signer has some intelligence about zones. It will take in a sign zone, knows what signatures need to be generated, will do the NSEC and NSEC3 chain, can spread signatures over time, given a jitter, well, all kinds of things to make operations go nice, update serial number, and so on and so forth. And this all works like a charm. Finally, there is input and output adapters. Input adapters, currently there is only one type of input adapter, that's a file. You take a zone file as an input adapter, and a zone file is written out, and that one is signed. Very simple. The next version of OpenDNSSEC will have an input adapter that is IXFR and AXFR, zone transfers. So in that case, you don't even have to put it, you don't have to even get it write access. You really put it on the wire. You have a master server that sends its AXFRs and IXFRs zone transfers towards the machine. The machine does the signing and pushes it out to the environment elsewhere. Other machines can do zone transfers from this again. But currently it's file-based, so if you do a change in your file and you resign your zone, it will say, kick the name server and say, spread this load. Anyway, and that works. Modular nature, each participant could do its work separately. We at NL Labs have been putting a lot of work in that signer architecture with the modules and in the enforcer. We work in a team with very many regular phone conferences. Code checking using all kinds of tools to prevent memory leaks and null pointers and God knows what. And just as the NLNet team itself, nothing gets released without a proper review by a second person. All code is reviewed. Testing, well, running OpenDNSSEC. If you want to do that, read the documentation. That's the documentation. www.opendnssec.org. There's a bunch of files you want to need, configuration for the overall system, the key signing policies, the zone lists, basically saying I've got these zones and I want them all signed and I want to have them signed with a specific policy, and then some configuration about how to get zones and how to push them out. It uses timing with a specific notation, period, 1 day, 12 hours, well. It only works with periods, because periods are the thing that we care about. I don't want to go through the configuration language and the details here, but it's basically, you know, you set up a policy. Most of the things you only have to do once. Auditor configuration, the policy configuration is stuff you want to do only once. So I'm not going to go into that. The fact is you can do basically everything here. And once you bound the policies to your zone fetching, you finish your configuration. This is the thing that you want to do once. And once it's done, you start daemons and you're in business. And adding zones is fairly easy and removing zones is fairly easy. Obviously, you would have to read documentation and work with it for a day or two before putting it into real production, but that is something you do with any kind of piece of software. If you do bulk signing, have a look at this. Really, this is important stuff. Otherwise, you won't be able to do bulk signing. It is used in production by several TLDs. Sweden, UK, Denmark, NL. NL will be using it, I believe. Anyway, I wanted to plug this. We're currently working on a rewrite of the enforcer. It's been written from the ground up in C, nice and fast. We're working on a rewrite of the signer, making it more fast and making it able to do the input and output adapters of the IXFRs. And that's expected in alpha in a month or two. And that's the part of active development of OpenDNSSEC. Oh joy. Who is still awake? I see only 3 hands. Oh, 4 or 5, okay. In that case, I should say, wake up. Questions this far? Don't be shy. I have a lot of material here and I'm running out of it fast, but let me do one final thing. So now, suppose you would like to do DNSSEC. What do you need to think about? And I'm now talking specifically about the authoritative side. We talked about the validating side. The validating side is 2 things. Teach your staff to troubleshoot, let them play with this stuff, and turn on a switch on named or on unbound and run with it. It's very simple. Get the root key, configure it, done. That's the validating side. And of course, done means you also have your trained staff. At the recursive name servers, or at the authoritative name server side of the picture, the story is a little bit different. The story is a little bit different because you have lots more things to worry about. We just talked about key maintenance, for instance. Yeah? But if you're a parent, for instance, if you have delegations down, or if you're TLD and you've got delegations down, you also have to do interaction. You have to think about your provisioning system. So let's go through some experience. It's old experience, I should say. I did this more than 5 years ago, but the overall experiences here still are valid. And so I will tell you one thing. Once we're done with this presentation, it's probably going to be coffee break. After the coffee break, I would like you to return, and I would like you to all get a piece of paper. And I want to ask you to write down a series of steps that you would take to deploy DNSSEC in your own organization. And I'm going to handpick a few people to step forward and describe what they wrote down. So the homework that you will get for the break and shortly after the break is write down what you would do to deploy DNSSEC in your own organization. Are you going to do that on your validating name services or not? Are you doing that authoritative? What are the types of things that you're going to look at before doing? So write the 1-page project plan. That's what I'm going to ask you. And I'm going to ask a few of you to present it, randomly picked. Now, I should have left those USB keys for after this break because I'm afraid that many people will not return after the break because this is, of course, a little bit of a challenge, but we'll see. Again, this is the generic picture. We have on the left side of this beast, we have the provisioning with registrars and registrants, possibly, and a registry back office. And out of that registry back office comes zones. Income registration, outcome zones. There's a WIS database, there's all kinds of customer stuff that you need to take into account. Well, what is the registry's core business? I would say the registry's core business is maintain who is the authoritative user of a domain name. They have to know who uses coca-cola.com and what is the billing address and what are the name servers affiliated with that. That's the core business of a TLD. Would anybody disagree with that? It's unfortunate that Helmut walked away. He could have said no or yes. But in fact, that's what they have to do. Maintain a relation between the domain name, a number of technical parameters, and a billing address. And they have to publish part of those relations, not the billing address, but the technical stuff, in the DNS. People trust the DNS because the TLDs in general do a pretty good job of that. Coca-Cola.com, we still know that we end up with Coca-Cola.com. There is some trust in those relations. What changes if you do DNSSEC? Well, not much. What you have to do is you have to be able to do DNSSEC aware provisioning, you have to do zone signing, and you have to make sure that your infrastructure, the name servers out there, actually understand DNSSEC. Very important step. If you serve DNSSEC and one of your servers does not do DNSSEC, you have a problem. Because what happens is that if I ask a question to a server for DNS information, DNSSEC information, that server needs to know all the tricks to, for instance, include the appropriate signature, an NSEC record, a DNS key set if needed. If a name server does not understand DNSSEC, for instance, if you have one Windows name server in your name server group that doesn't implement DNSSEC, then don't start doing it, because you will break stuff. Yeah? Make sure all your authoritative name servers speak DNS. In terms of deployment tasks, you need to come up with key maintenance policies and tools. How do you use the private keys? How do you do protected? How do you do the public key distribution? How are you going to publish it in the DNS? How do you do zone signing and integration into your provisioning chain? Are you going to use web-based forms? Are you going to do WHOIS information? What is your current things? What are the current things you use to interchange those technical parameters with your clients? Those things change. Let's have a look at key maintenance. Public key cryptography, that's what we talked about. Data is signed using a private key, it's validated through a public key. You need to disseminate that public key and you have to make that private key private. Private keys have a best before date, you have to change them so now and then because they get operational exposure, somebody might steal them or whatever. And if the keys change, you have to make sure those changes propagate through the system in a good way. That's what I talked about in the last block. In theory, only one trust anchor is needed, that of the root. How does the root key to get to the end user and how is it rolled? Well, we talked about that. RFC 5011 technology is used for root key. That's something you don't have to worry about. But if you are in an enterprise and your security policy says, don't depend on externalities, you have to think about how to get your key to all those recursive name servers out there. And you have to think about what technology you use, RFC 5011 for instance, on how it's rolled. This is for early deployment, mostly. At the RIPE NCC, when I was working there, what we did at that moment is we said trust anchors are published on an HTTPS secured website, signed with the RIPE NCC public keys, that is PGP keys. We used a different mechanism. And we said in advance, trust anchors will be rolled twice a year, and any announcements about this will be signed with PGP and S-MINE when we send them to a well-known list. So we set up a policy, and we told everybody this is the policy we will be following, and any changes to this policy will communicate securely in order to prevent social engineering. Fortunately, the world has changed a bit. We now have 5011 key type rollovers, and we have a secured root. So this might not even be relevant for your organization. Thinking about how public keys get to the recursive name servers that do validation might not be relevant if you run name servers. Key management, and I told you already, key signing keys, zone signing keys, rollover, multiple keys available. Everything needs to be consistent. What is in caches, what is in your zone file. Things need to be able to validate with each other. RFC 4641 again has a lot of detail about that. And your private keys need to be secured. There's a bunch of approaches you can take. You can use a smart card to store the key signing key. You can use hardware signers or key management software. Yeah, writing your own software is possible, but you can also download OpenDNSSEC and run with that. At RIPE NCC, when we deployed, we didn't have OpenDNSSEC, so we wrote our own tool set based on Perl tools called NetDNSSEC, which were a front end to the bind signing tools. But this architecture is actually pretty similar to any sort of environment, where you have a zone database, basically your provisioning system, and you have a DNS server. And what you want to do is you want to do something here that introduces DNSSEC. It's the bump in the wire idea. So what we did is we had a little signer client that took the input here and signed it based on a key database and signing server that had all the information about the keys that were there. And that was all shielded off in a little neat box to which only key maintainer had access. And we called out a special role, a special management role, saying somebody is the key master. That person is responsible, has in its contract, and you are responsible for maintaining the keys. And that's important. If you introduce DNSSEC and it doesn't, not only DNSSEC, but just any security mechanism, make sure somebody is responsible. Make sure that somebody knows they get fired if they fuck it up. That sounds blunt, but unfortunately that is the way it's sometimes needed. Give somebody real ownership about maintaining those keys, logging into the system on a regular basis and making sure everything is in order. Because if you do so as a manager, you also notice that if that person moves from one organization or one department to another department, that you're lacking a skill set. If you deploy DNSSEC without thinking about all these things and everything will work, then what you'll see is that as soon as somebody switches departments, things will break. So as a manager, think about these responsibilities and roles and write them down. Yeah? And if you go back and you're the techie in your organization, then you can do some upward management and say, hey boss, I'm going to deploy DNSSEC, and what you need to do is you need to write this into my job description so that we don't forget it. And while you're at it, give me a pay raise. But anyway, at which point the boss says, no way, no DNSSEC if you want a pay raise. But that's another story then. Anyway, what we did is basically, a key database that maintains the keys. This is OpenDNSSEC in an earlier version. I'm not going to describe this because this is really out of date. But you can do this stuff yourself if you want to. If you don't trust third parties to deliver your key management systems, you can actually write them yourself, and people do. OpenDNSSEC is not the only tool around. There is a tool called RollerD from Sparta. I believe it's sparta.org. They also have a daemon that does key rolling and things. So you don't need to rely on one solution. I'm going to stick at this, OpenDNSSEC. So think about key management. Key management and also in your organization, who is going to be responsible? Part one of your project plan. DNS server infrastructure. Very important. You need to make sure that your primary and secondary servers are DNSSEC protocol aware. Yeah? And they need to be able to work with DNSSEC. When we started this, we had concerns about memory, CPU, and network load, and some research was done and published as RIPE document 352. This is old stuff. This document is 6-7 years old. But take that as an inspiration, and in the general gist of this still holds. The general methodology that we took to look at this still holds. We looked at that time at what it would take to deploy DNSSEC on one of the root servers and on the server that is authoritative for the RIPE authoritative zones like RIPE.net, but also all the reverse address zones that RIPE maintains. RIPE NCC is the LACNIC counterpart over in Europe, as you know. CPU, memory, bandwidth, they increase, but the conclusion was that was not prohibitive. Bandwidth increase is significant. You have to take that into account. If you're now running a DNS system and bandwidth is of a concern now, then DNSSEC is going to push you over the limit. In general, if you're now close to the edge of what your name server can do, you really have to upgrade. But in general, the impact on CPU is small and the impact on the memory can be predicted. What we also found out was that at the moment we did this test, there was data added to the additional section, which was not necessary. So we used the Distal Test Lab. The Distal Test Lab was a test lab that we still maintain on the Nelnet Labs. At that time, I was working at the RIPE NCC and I was collaborating with the Nelnet Labs. That's how I got to know the guys, for which I'm now directing. This is, let's see, 2005. But essentially what we did was we set up a test lab and we had a player sending out queries to a DNS server and then recording the answer and making sure everything was consistent, and we could actually do measurements about, you know, network load and all those little things. And as RIPE.net, 133 zones, K-root only with the root zone, zone signing key with a 248-bit RSA-CA1, two zone signing keys, you know, the rollover, you introduce a new zone signing key prior, so there's often a period where you have two zone signing keys, only one signature, so you had three DNS key errors in the zone, one RR-SIG per RR set and two RR-SIGs over the DNS key RR set. This was the content of the zone, and then we started loading mixtures of zone sizes and tried to figure out what the load was. Well, based on the type of operating system that you use, FreeBSD 6.0 at the time, or Linux, you could see a little bit of differences in the memory allocation functions there that put stuff in bins for named. But what we saw is that the memory for NSWrite.net went from 30 MB to 150 MB. That is a significant increase, 5 times, but on machines that we have today, which have at least 1 gig of memory, this is noise. If you run a big name server, like Brazil or Germany or the Netherlands or .org, then we're talking going from 6 gigs or 8 gigs to 32 gigs. And the difference are significant. There's a tool at the NLNet Labs website where you can calculate the memory requirements for your name server based on the number of delegations you have in your zone and the number of A records in your zone and so on and so forth. So you can have, the message here is you can calculate the memory requirements for your zones at least to an order of magnitude, and you don't have to get surprised. Yeah? So this is something you can do this kind of thing you can actually do tomorrow. Serving signed zones, at the moment that you turn on signed DNSSEC, you should expect questions that require DNSSEC answers. 6 years ago, at least 1/3 of the questions asked to K-root said, give me DNSSEC. What we saw at that time is that for K-root we went from 38% CPU to 42% CPU using bind. For NSD at the time, same load, 4% to 4%. The modification here meant if everything was DNSSEC signed, then we would have a load of 50% and 5% for NSD, which means, don't worry. What we did find out after we did the implementation is that if you are over half of your CPU, then things become non-linear. So you really, if you're close to half of your CPU, you probably want to have a machine upgrade. Also, NSD is really low on use of CPU time there. Bandwidth factions. Well, there will be an increase of bandwidth. That's for sure. You just stuff more information over the wire, and that depends on your key size, your zone signing key size, and your key signing key size. Now there is a difference. Basically, a factor of 3 to 4 increase. Is that a problem? I do not know. There is a difference here between the behavior of bind at that version, this difference doesn't exist anymore, and the behavior of NSD, given the amount of queries at that time, the behavior, the increase of bandwidth use was not that high for NSD at that time. Worst case scenarios, about a factor 2 to 3 increase in bandwidth use. This is old material, so I'm going to skip over that. Can you deal with TCP? What is the effect of NSEC3 hashes? All kinds of those questions. There is some material on the DNSSEC training site where we did more research, which can also be found on the documentation section of the NLNet Labs website. We wrote some technical papers about that. If you go to the website DNS School, there is a drop down there. Finally, so what we did is we have key management in place. We've got our servers. We've got it all figured out. We've got them upgraded. But now we need to do the provisioning. You have to think about your provisioning. Providing secure delegations or input of data. Well, input of normal data is probably not a problem. You've got a zone file now which you construct in a certain way, and you only have to bang that through the signer, and you've got signed data getting out. If you want to do secure delegations, things become a little bit more tricky. When do you want to do secure delegations? Well, if you go from one layer to another, TLDs all have to do it, but also in companies you sometimes have an infrastructure where certain departments have to maintain a certain part of the DNS tree, and you want to make sure that they can actually do that as well. So they have to go through this motion as well. Providing secure delegation, well, normally you have an NS record. What you do is you add a DS record. There's not much to it. The exchange of DS record has exactly, and I say exactly, the same trust properties as the exchange of NS records. If you trust a change of NS records now, you can use the same process to exchange DS records. But once you get to think about this, you will notice that maybe there is a bug in your key exchange or in your NS exchange mechanisms. For instance, what we noticed at the RIPE-NCC when we did this is that the provisioning system was based on updating whois information. And the updates of whois information, if you were a man in the middle, you could record that update of the whois information and replay it back like 2 months later, and redo a specific change. So suppose that you would record a message, and after half a year somebody changed the name service, you would go and send the message, resend the message, the system would accept that message and put the change back into the original situation. That could lead to a denial of service attack or some embarrassment or so, or what. That is something we started to notice because we looked very carefully at each step in our provisioning process, what needed to happen if we do DNSSEC. But in essence, the idea that was rooted behind the introduction of looking at the provisioning in that way is that we said, let's try and use the same interfaces. Let's do not make big changes to whatever we do. Offer clients something that they're familiar with. You might want to consider doing checks on configuration errors. For instance, if you get a DS record from a customer, make sure that it points to something that is existing. You might even want to consider doing some checks and say, whenever I find a failure, I do automated checks all the time, and whenever I find a failure, I will inform the customer in some way or another, using out-of-band mechanisms or so. If you have customers, provide them with tools. Think about the kind of tooling you want to do. If you're a hosting farm and you want to provide DNSSEC to your customers, think about the tooling. Maybe it's only say, yes, I want to do DNSSEC, click this button, and everything is done in the backend by the hosting providers. Maybe you want to give the user more elaborate tools where they can pick their own policies, for instance, for zone key rollover and so on and so forth. I would advise against it, keep it as simple as possible. Does DNSSEC change your core business for TLDs, for instance? No. A TLD maintains who is the authoritative user of a domain name, maintains a relation between the domain name and a number of technical parameters. The DS is just another set of technical parameters. It's a stream of bytes, information. As a TLD, you're responsible for maintaining that. There's nothing different. If you're not secure, if you're not precise with NS records, you shouldn't be handling NS records in the first place. If you're precise and secure with handling NS records, you can deal with DS records as well. It's fairly simple. Recursive name service. I think I talked about this. Recursive needs little crypto. So the resource needs. If you look at the additional resource needs, if you're going to do DNSSEC, well, currently very little zones are actually signed. If you turn DNSSEC validation on today, your box is not using the resources on doing every single query, doing DNSSEC validation. The longer you wait with turning on DNSSEC validation, if you turn on DNSSEC validation as one of the latest, then you really have to think about the resource needs, the CPU, memory, and so on and so forth. What do you need to turn on DNSSEC? If you turn on DNSSEC today, the resources are not your primary concern. There's so little stuff signed out there, not really needed. Do think about troubleshooting. We went through a set of troubleshooting tools a little bit earlier. Think about how to make sure that your engineers work with those troubleshooting tools and do things with that. If you maintain a trust anchor, make sure there's somebody responsible that knows what that thing is and what it means and how they can troubleshoot it if it goes wrong. Again, a trust anchor is a crypto token, and with every crypto token you need to make somebody responsible. Let's see, what is this? Oh yeah, sorry, I was thinking about what this picture is. What you see here is two curves, one for bind 950 and one for unbound 111, both old versions of the software. And this is not a comparative test, but to give you an idea what happens. This is the amount of queries returned at 99%. So 1% of the queries get dropped because the server is too busy. So what we do in this experiment is we max out the server to a certain percentage where we say you need to answer at least 99%. And then we count the amount of queries that are returned at a certain percentage of DNSSEC deployment. So this gives you a feeling for what happens with the resource needs in order to maintain a reasonable service level. And what you see that if there's 20%, roughly 20% deployment of DNSSEC, both for bind and for NSD, you find a drop of about 50% in query rate. The thing is, if you deploy DNSSEC today on your validating name servers, you go with the flow. You follow what your name service is capable of, and you don't have to do a step function, and you can just put it in your system and look at what the resources needs are and deploy appropriately in normal deployment cycles. If you turn DNSSEC later, when it's deployed for 40%, you're actually going to get a performance hit, which you might not have expected. So be careful with what you do. This is with 66% cache, key sizes of 258, Ubuntu server on an AMD Athlon with 1.5 gigs of memory, 2.4 gigs of CPU cycle time. So very commodity little machine, nothing there. But you can see roughly 5,000 queries per second easily. Those are numbers you can come home with. This is the network, the amount of network resources you need. Transfer in and out. You see with unbound it doesn't make a lot of sense to bind a little bit more. So far those numbers. It's also a natural time to have a break. So remember the exercise. When we come back, it's time for questions, and I'm going to ask you also to write down that project plan, and write down for yourself what you wanted to achieve, how you would deploy DNSSEC in your own organization. I'm going to ask a few of you to the stage, and and you can describe your organization if you are an ISP or if you are a name server operator or if you have you are in any other business, how you would deploy DNSSEC, what you think are the most important pitfalls, for instance. What are the barriers you need to, is there management pressure you need to overcome? All those aspects, please think about this, write this down in a few keywords so that you can speak to it when you get back. And I hope you all have the courage to come back after giving you this little exercise. Once the exercise is over, I'm going to ask you to go back to that first sentence that you wrote down. What do you plan to achieve during this meeting? And I'm also going to pick a few people out of the audience and ask, did you achieve what you wanted to know? What can we improve? Do you have any questions? And maybe we can have a little bit of an open discussion on plans, ideas, and approaches. So we're going to do some open experimentation. I went through a lot of material, I realized, and we went over the material very fast. Normally this is a hands-on course where we mix all this theory with actually doing some hands-on work and seeing things happen in real life and get a little bit more of a feeling of what all these little bits and bytes mean. But I hope you basically got an overview of what is needed and what needs to be done. So I hope to see you back after the break. It's now 4:15. Let's come back here at 4:30, and then please start writing as soon as you can. Thank you. The applause can come after we finish the whole course. I expect you all back.